So we'll slide over and do hypothesis testing for two proportions or a two-prop z-test. Um, Before we move forward, that's a couple of review questions up at the top of the page there. So a local real estate magazine uses the median instead of the mean to report the average SAT scores for this high school. So why in this situation the median would be more accurate as an indicator? Remember, median and mean can both be affected by outliers, but one is more severely affected. Remember, mean can get pulled a lot by an outlier. And so the appropriate answer here is A, the mean is affected by a skewness, whereas the median, it can be, but it's hard to move the median with just one or two outliers. The second review question, a recent study conducted to investigate the duration of time required to complete this task. So apparently it took 10.2 seconds with a standard deviation of 16 seconds. So this, just as a heads up, that looks like a sigma value. Oh, excuse me, there's the answer. That was like a sigma value. This would be a t-test, not a t-test, excuse me, a z-test. If we're looking at this, if a random sample of 144 people is selected from the population. So if you want to see what that would look like with your graphing calculator, uh, I'm going to run a z-test, notice. Here's all this information, and it's greater than, that's why I've selected that particular option there at the end. So I'll go down here and I'll calculate, and really when it's asking for the probability, what's the p-value? So there it is, 0.274, and sure enough, the answer, 0.274. So you're just running a one sample z-test right there because 16 is a sigma. All right, so here we go. For a two-prop z-test, the details of the test. Now, hypotheses this time, we're going to compare P1 and P2 instead of the mu's like we did previously. Remember, equality, equals, greater than or equal to, less than or equal to, always goes with the null. Greater than, less than, and not equal to goes with the alternative every time. The conditions for you. Each proportion must be from a random sample, so randomness, that's not changing. Each population is greater than 10n, so that's where you just have to separate that and do population 1 greater than whatever n1, and then population 2. This one, this is the first time that you're actually going to see pooling. And what you're going to do with the pooling here, you see p hat pooled and q hat pooled. So it's still that np, nq greater than 5, but it's not p hat in the sense that we're used to seeing p hat. This is p hat pooled. And what a p hat pooled or p pooled value is, you just total the successes and divide by the total of both sample sizes. We'll show you, that'll play itself out here in just a little bit. So just make sure we got the hypotheses down, the conditions that you need, and then here's the test statistic. Again, p hat 1 minus p hat 2. And then the p's in the standard deviation are the p pooled value. And the idea here, if you go back and you look at your null hypothesis, the null hypothesis here is that we are claiming that the two values are equal. All right? This is what we, most of the time the null is always equals. Even if it's greater than or less than or equal to, there's still equality inferred, if you will. So because we're assuming those two things are equal, what we're going to do is basically put them together. We're going to pool our values. That's where pooling comes into play for us. So you notice with that two sample test, that two prop z test, understand this p hat, these two p hats are exactly what you're used to. And when we go to the calculator, you're going to see everything's going to kind of play out for us, and it's going to be labeled well. And it'll say p pooled in the calculator, so we're not going to have to guess where things go. So if we go to that first example, filling in that chart, we get a couple p hats there at the end. So read through the example, you fill in that chart, and then we're going to switch over. I'm going to switch over and just kind of write through the test here instead of just letting the PowerPoint do it. So here we are on the back. We're going to kind of start picking through this thing, right? So out of these 1,010 adults, 995 respondents, 37% of adults report that they snored. 48 out of the 184 under 30 snored, while 316 out of 811 in the older group, or 30 and over, Is there a difference in the two groups? So this is a two-prop z-test. We're comparing two groups, two proportion z-test. There are no degrees of freedom with z. Um, we'll go ahead and label our population 1 as the under 30, population 2 over 30. So our null hypothesis, I don't see any indication otherwise, will be that those two things are equal. And then the alternative, is there a difference? So P1 does not equal P2. My conditions, both from a random sample. So are they both random? Split into two categories. Oh, yep, that's actually given at the very beginning. It says they're random. So we need more than 10,000 or 1,840 and more than 8,110. So under 30, 30, and over. And then here's where we need just we're gonna have to kind of give ourselves a little bit of room here. So 184, and we have to get that P pooled value and that Q pooled value. But if stick with me here in just a second, the calculator is actually going to take care of that for me. And then we have 811. I'm not going to figure that out right now on my own. You're going to see. We just want to make sure those are all greater than 5. So there's my conditions. All right. So let's just go through. We got to fill in the formula very quickly. So we have a z-score. P hat 1 minus P hat 2. So we had 0.26 minus 0.39. Just like the muse, this is minus 0. And then here, I'm going to need that P hat, that P pooled and the Q pooled. So at this point, it's time to go to the calculator. So to the calculator we go. And what we want stat. We're going to go over to test. This is a two-prop z-test. So x1 for us is 48. N1 is 184, X2 316, and here's 811. One thing to notice, they don't ask if you want to pool or not. The calculator in this case actually already knows, hey, we're going to pool because it's a two-prop z-test. Just as a heads up, anytime you're asked to pool, our answer is always no. Our hypothesis is not equal to, so we'll go ahead and calculate it. So we got a P hat 1, P hat 2, and then you just see that P hat sitting right here. What I'm pointing at, that's your P pooled value, so 0.366.37. So 0.37 is my P pooled. So P pooled, this is something, just jot this down because that's the value that we want to put in all of our formulas. So 0.63 will be Q hat pooled, and then all that's over, right? Just as a quick reminder, all that's over. We flip back over here. Right? Oh, excuse me. I didn't leave myself enough room, right? We want N1 and N2. So let me go back here. Let me give myself a little bit more room. I'll just write smaller. So 0.37, 0.63. You're just going to repeat that. This one's over 811. This one's over 184. So all of that fun stuff is equal to, pull my calculator back up. So the z-score negative 3.27. We'll use an alpha of 0.05. So our p-value, again, if we're looking at that screen, the p-value for us, all the way, oh, excuse me, it's right underneath 0.001. So this is not very likely. So 0.001 is definitely less than 0.05, meaning we'll reject the null in favor of the alternative, which means that we are going to claim evidence suggests that there is a significant difference. There is significant difference in proportion of snores in relation to age. Let's do one more. I realize this video is going to be a little bit longer, but let's go through this next one so you kind of get the feel for this p-pooled value. So 430 randomly chosen adults. So right away, I already know that randomness is okay. So both random, that's given to me. Here I go, I'm doing the conditions at the beginning. Right? 21% of the 22 men and 18% of the 200 women. So there were, I don't think, 430 minus 208. This should actually be 222. So there's a typo, fix that. So the men, there were 222 men, 208 women. So the sample proportion of men was 0.21. The sample proportion of women was 0.18. So one, make sure we go back and fix that one error. So we got 222. We're going to get that p-pooled value, right? We need p-pooled. We're going to let the calculator do that for us. If you want to see what it would look like, you just do total successes over total sample size, and I can show you that in a minute too. I don't know that number off the top of my head. We're going to have to actually backfill the chart as well. And then we need more than men and more than 2,080 women. All right, this will be, is there evidence that men are more likely? So right away, the initial thought, we'll call men population 1, women population 2. So initially we're going to claim that they're equal versus the alternative that men are more likely, so they're greater than. This is a two-prop z-test. And here's where we're going to have to backfill. In order to use the calculator, we need those two values. So it's pretty easy work here. So for the men, right, x over 222 equals 0.21. So just multiply 222 times 0.21. So it looks like there's 47 men. It would be 46.6, but same thing for women. So for women, we have x out of 208 equals 0.18. So 208 times 0.18, 37.4. So we'll round that to 37. So now we can go to the calculator and fill all this information in. I can start, I'll go ahead and put my z. So 0.21 minus 0.18 minus 0. You still have to put that in there, so don't get lazy on that part. And then from here, I need the p-pooled value to fill in the rest of this. So I'm going to pause the video on my end. I'm not going to sit here and you're not going to have to listen to me type everything in and watch me type everything in. But in just a moment, if you want to pause the video to type everything in, then then unpause to check your numbers. Go ahead and do that. So my p-pooled was 0.20. So fill that in. The z-score was 0.88 and a p-value of 0.19. So at an alpha 0.05, 0.19 is greater than, which means we would fail to reject. And then I'll leave the rest up to you. So evidence would suggest that the two proportions are equal. It's equally likely that men and women purchase books online.